Okay, so we have 2-5, day 3. We're looking at page 37 to page 41 in your notes, and we're looking at using complex zeros to factor a polynomial. Today, however, it's not like we're doing reals like we did day 1, and we're doing complex like we did day 2, and now we're doing focusing on one particular. Read the question today and pay attention to the wording, because the question itself will tell you how I want you to frame your answer, okay? And more so, how I want you to frame your answer on the test. When we're looking at this, given that 6i is a zero of f of x equal x to the fourth minus 2x cubed plus 38x squared minus 7x plus 72, find the remaining zeros and write it in its linear factorization. Okay, now when we're doing this, we gotta first check 6i. But then we do negative 6i because they happen in pairs. So that's the first thing we're going to set up. Maybe we're going to set up, or we're just going to do, okay, all right. I was just going to like burn the ships and just start doing it. So I like being out of your way. Go ahead, start this, start working through, and remember, every time we have a complex value, we have its conjugate as well. So let's just do this as our warm-up. As I'm taking attendance and wandering around, see how far you get. Do 6i and do the negative 6i and get her going. Okay, remember, when you're working with the complex ones, the first one's always harder than the second one, and then after you multiply to the second one, it starts clearing it out. So make sure you recognize that. I'm going to give you some time. I will. I just gotta do attendance real quick, because otherwise I'll forget, and they're like, Bloom, you didn't do attendance. And I'm like, yeah, I know. Okay, so we got a couple people going today. That's kind of a bummer. Okay, so let's start talking about this. So I got 6i. I'm going to take and drop the 1, and I'm going to multiply 1 times 6i. So I'm going to add 6i to negative 2. Well, when I do that, because they're different terms, I've got to consider the fact that, well, gosh, I got my 6i up here, and I add it, and I get negative 2 plus 6i. Okay. Now, I multiply by 6i again. Okay. So I've got negative 12i plus 36i squared, or minus 36. So I've got that minus 36, okay, when I do that. But before I start, is everybody okay where I got the minus 36 and the minus 12i? Okay, so 6i times negative 2 gives me my negative 12i. 6i times 6i gives me my negative 36. Now I can combine my 38 and 36. That's 2 minus 12i as I'm working through. Okay. Now, I can almost guarantee you will be doing something like this on the test, okay, to this effect. Something like this, or something with the complex conjugate with a little extended with that trick of multiplying that we're going to do in the next one, okay? I promise that they'll both be there, okay? Multiply 2 times 6i. I got 12i minus 72i squared, which is plus 72, and that'll take care of my 72, so I got plus 12i. Now I'm going to multiply by 6i yet again, but 6 times 12, 72, and that I squared becomes a negative 1, so I got negative 72, and I get to say it's 0. Are you all right with the process that I'm going through? Friesen, you got a furrowed brow. You're okay? I'm not taking it personally. I don't think you're mad at me. Okay? So, are there any follow-up questions with multiplying by 6i? Now remember, every time we work with a complex value, because we have real integer leading coefficients for each of our functions, and every variable has an integer in front of it, we have to multiply by its conjugate so we clear out those i's, the imaginaries, from them, because they're all real values in these polygons. So we have to consider negative 6i. So we dance through this next one. 1, okay, times negative 6i is negative 6i. But this is nice because it clears that out and becomes 2, negative 2. Okay? And then I do the next one, and I've got negative 6i times negative 2, which is positive 12i, and that clears out my negative 12i, so I got 2 again. I multiply that, and I got 2 times negative 6i, and it's going to give me a negative 12i, and I get 0. Maybe. But now I'm at a point that I need to find the remaining zeros, and I have a choice to either complete the square or do quadratic formula. And I'm going to be honest, I prefer completing the square. So we're going to go up here. We got x squared minus 2x plus 2 equals 0. I'm going to complete the square by finding my other 2 zeros, okay, of this function. I already know the first two, 6i and negative 6i. And why I can say it's the other 2 is because it's to a power of 2, okay? So now, I've got x squared. Half of negative 2 is negative 1 squared, which is 1. So I've got negative 2x plus 1. And the difference between 1 and 2 is 1. There should be a negative 1 on the other side. Okay? Are you okay with what I did? The left is a perfect square. I took that and extracted the information from what was there from 2 and pulled that across. Okay? Questions how I'm doing that, 'cause it's a little different than I've done before. Like I just subtracted 2 and I wholesale added 1 to both sides. The result is still the same. Okay. Now I got my perfect square, x minus 1. There. Now I'm going to take the square root of both sides, which remember the square root of negative 1 is I. So I've got x minus 1 equal plus or minus I. And make sure you're careful about your notation. As soon as you put that little one-looking, I-looking thing down without a dot on top, it could be a 1, it could be an I, who knows, okay? And you could forget and evaluate it incorrectly on your next step. So just pay attention to that. And I got x equals 1 plus or minus I as my 0. I got 2 of them, 1 plus I, 1 minus I. Are questions on how I got those? Feeling comfortable with those? Now, there's a possibility that as you're going through this, that you're not paying attention to what factors I'm interested in. So as you're finishing a question, always reread it, the directions, and make sure you're answering what you're asked to answer. So I'm supposed to find the remaining zeros and write it in its linear factorization. Okay? So my remaining zeros I have found, but I'm going to write it in its linear factorization, okay? And I'm going to list my remaining zeros, maybe. I didn't list them. So I've got my x equal, these are my zeros, 6i, and you go plus or minus 6i. And I suppose we could also go, hey, you know something? 1 plus or minus I. Or you could say 6i, negative 6i, 1 minus I, 1 plus I, to get your zeros in there. But remember, make yourself a list, make sure you have the factors all multiplied together. That will actually make your function, and make sure you have your function notation correctly listed and labeled. I have a tendency every once in a while when we have a function that I make it up, I just use f of x, but then they use it later as p of x or s of x, so I will go back and change it if I need to. But just in the habit, have it equal to something as we're going through. Questions about what we've done so far? Are we feeling confident about these? Yes, no, maybe. Okay. Now, sliding on, next page. I know we have 2 start here Fridays. We didn't do this one. We didn't start here on that day. So I'm looking at my function. I got 4x to the 4th plus 17x squared plus 14x plus 65. I got a complex 0, and I write in, bless you, 4. But I put in a 0 because I have a placeholder, because there's no x cubed value. Okay, I have to put in my x cubed 0. I got my x squared, my x, and my constant. Okay, and when I'm working with these 1 minus 2i's, or, you know, as I'm going through this, I have to recognize the fact of its complex conjugate. I'm going to have to search 1 plus 2i eventually. So that's my next one after this. And it's always nice to go in pairs because the first one's more difficult to do, but after you set it up, the second one just kind of knocks them all out and you're back to integers, so it's a little easier. So this one's the working one, okay? So I'm going to drop 4. 4 times 1 minus 2i is 4 minus 8i, okay? I'm not really doing anything with that. I mean, you know, I'm adding it to 0, but because that's my x cubed feature, make sure you pay attention to that when you're actually doing the test itself, because you get yourself so into this synthetic division, you'll forget to pay attention to the descending order of your polynomial when you're setting it up, and that's kind of a oopsie, okay? You'll do all that work, but it'll be incorrect, okay? So I got 4 minus 8i, and I multiply again by 1 minus 2i. Now, keep in mind, I've used some tricks to help me do some stuff faster at times, and this one, they're not a difference of 2 squares, so I'm just going to go for the distribution of the 2 variables. Thank you. As we're going through. So I'm just going to multiply 4 times 1, and in my head I'm doing the 4, I think I just wrote it out here. 4 times 1, 4 times 2i, that's where it's 4 minus 8i, and then negative 8 times 1 and negative 8 times negative 2, and I'm just making sure I did those correctly. Now I've got negative 12 minus 16i. Do you see where I'm combining them? Negative 12 minus 16i. Okay. So I got negative 12, so that's 5 minus 16i as I'm going through that. And I put all 4 of my multiplied values out. I didn't combine them. I wanted to make sure everybody saw how I did them. All right. Are there any questions about my 2 binomial combination? You okay? Promise? Yeah. No, go ahead. All right, I just want to make sure it's clear. I didn't use FOIL, okay? I just went, and when I'm looking at the 1 minus 2i times 4 minus 8i, like that, I distributed 2, 1, 4 minus 8i, okay, when I did that. And then I'm looking at that minus 2i, and I distributed 4 minus 8i again. So when I'm doing that, you got to make sure I got 4 minus 8i. Then I'm subtracting 2i times 4, which is 8i. And then I get that, ooh, that should be plus 16. Nope, that's going to be plus 16 as we go through. I think I made a mistake there. Negative 16. Nope, it's be I squared, and it'll be negative 16 as we come through. So I'm good. Whew. Okay. Are there questions, other questions about that combo? Yeah. When I have this value here, as I keep grabbing that top with my pens, I got negative 2 times negative 8, which is positive 16. But it's I squared. And I squared is negative 1. Are you okay with that? I knew there was something there, and that's okay. I want you to clarify those as we go through. So I've got an I squared, which is negative 1. That's where my negative 16 is coming from. Are there any other questions? Okay, so now I get that negative 12 plus 17 is 5, and negative 8 and negative 8 is negative 16i. Now I go back and do the exact same thing on this next one. I go 1 times 5 minus 16i. So that's where I get 5 minus 16i. Then I got negative 2i times 5, which is negative 10i. And negative 2i times negative 16, which is positive 32, but it's I squared again. And that's where I get another negative 1. Okay? So are you okay with my negative 32 at that point? Yes, sir. Foiling does work. It's just, I'm going to be real honest. I get kind of confused because of the I and the I squared. It makes it easier for me to do this way. I'm not saying you shouldn't do it another way. I just want to make sure that you see where I'm distributing it. Okay? And it seems in my head sometimes cleaner to do it like this so I can show you where I am and where all my terms are coming from to answer those questions that are like, well, wait a minute, where did that number come from? And I want to make sure that those are clear. Okay? So I'm not saying you can't. I'm just saying I'm just showing it this way so people can see where my numbers are. Now, again, I got negative 26i, but I got a 5 and negative 32, so that's negative 27. So I got negative 13 and negative 26i as I'm going through, and I multiply yet again. have you noticed when I said this that the work side is the first one? Okay, so I'm going to distribute that 1 times negative 13 minus 26i. That's my first one. Okay, and then I got positive 26i minus 52, because remember it's plus 52i squared, and I squared is negative 1, so that's where I get my negative 52. So now I got negative 65, and my negative 26i and my 26i are 0. So that's why this is 0 on this one when I combine terms. Questions regarding? Feeling okay? Now, ideally, in all honesty, we should have this be a 0 here, because we are told, hey, that's a factor, okay? So if we're working through this and we made a mistake, some people go, oh yeah, I know it's gonna be a 0. I actually check every one of your entries, okay, when we go through these, okay, to make sure that you're following through and that's what it is. Because I always have people, oh yeah, it's supposed to be 0 there, and he won't look at it. I do. This test takes, it's like 7 questions that take forever. I do a question almost, it feels like a day, just to make sure I've covered. If I can do 2 of them fast, fantastic. Okay, but now the next one, because of the conjugate, I got to go 1 plus 2i. This one's much easier because it ends up starting to clear out everything. So I'm looking at 4 times 1 plus 2i, so I got 4 plus 8i. So now I got 8 as my result as we get going, maybe. And I'm going to multiply 8 times 1 plus 2i, which is 8 plus 16i. Well, 8 plus 16i is 8 plus 5, which is 13, and the 16i's knock each other out. Now I got 13 times 1 plus 2i, which is 13 plus 26i. And again, my 26i's are taken care of, and my 13 is as well, because that's a 0. And be truthful, when we're using complex values, the first one is always the more difficult of the two. Okay, that one just tripped out really quick, okay, when we did it. So know that the first part is some work. Now, the next part of this is I'm finding the remaining zeros and write it in the linear factorization form. So although, you know, I've got my zeros, I'm still going to write it in my linear factorization form, and I'm going to give a list of zeros as I'm done. But now I'm at 4x squared, and I'm just going to do this clean. At 4x squared, I can do that. We'll get this out of here. I got 4x squared here, plus 8x, plus 13. And that equals 0, because what's my goal here? I'm going to find my zeros, okay? Now, I'm going to divide by 4, okay? And because I need to get my leading coefficient when I'm completing the square to be 1. So I've got x squared plus 2x, okay, plus 13 fourths equals 0. I'm going to push that to the other side, x squared plus 2x plus, what's half of 2? 1 squared, 1, okay, plus 1 equals negative 13 fourths plus 4 over 4. Are you okay that I just added 1 in terms of 4 fourths, so that way I can combine like terms and come up with negative 9 fourths on my next step? Okay, now I've got a perfect square on my left. So I've got x plus 1, totally squared, equal negative 9 fourths. Now I'll have some people on the test go, well, Bloom, this is going to be negative. There isn't a solution. It's imaginary. I expect you to look for that imaginary solution at times. And in this particular case, we're asked to. So make sure you're careful about where you decide to say that. I'm going to take the square root of both sides. I'll use this space up here. Square root of both sides. I've got plus or minus the square root of negative 9 fourths. Okay, negative 9 and 4 are both perfect square, which is fantastic, but I got that negative in there, and I've got to reflect that as I. So x plus 1 equals plus or minus 3 halves and 3i over 2. Okay. Now, my last thing, I've got x equals negative 1 plus or minus 3i over 2. So are you okay with my other two zeros that I needed to find in this function? Yes, no, maybe. Now, heavy factoring, heavy multiplying binomials, trinomials, quadnomials on this test. Okay, be comfortable with it. Yes, Ms. Tim.
So you pulled the 4 out at the beginning.
I divided the 4 out. Yeah, be careful. Yeah, I divided that out.
That doesn't matter in the final answer, does it?
It will. You will see it in the final. We'll talk about that when we get to that. When I'm looking at that, remember I divided that out here, so really it's in here. It's in my answer. It's considered. I didn't just drop it away. So it was something I divided through. Okay, so I worked with it. That's where it's 13/4. Okay, I could have pulled it out, but then I have to have multiplied it out. I have to have it considered in my answer. So when I'm finishing up, I've got that, okay, as I'm talking about it. And when I'm looking at this, okay, we have that 4, we divided it out, and now since I divided it out, I'm putting it back in, okay. And I'm looking at that, I got 1 minus 2i, 1 plus 2i, okay. And I'm putting it back in there, and I'll make that adjustment in my final pretty answer as I finish. Okay, and I decided to take 2 into there and there, so I broke my 4 down. So yes, but I put it back in. Now, my zeros were 1 minus 2i, 1 plus 2i, negative 1 plus 3 halves I, and negative 1 minus 3 halves I. So I have my list of zeros as I go across as well, okay? So I can like put them all together because you'll be asked about linear factorization, which is just multiplying your binomials back together, and your list of zeros, okay? And remember, read your questions. There are people that will not give me the list on the test. I'm looking for them because I'm asking for them in the directions, okay? Now, as we slide on, maybe, if it ever gets to it, factoring with real number coefficients. If f, now, notice, up until now we've been doing complex in the conjugates, but now we're factoring with real number coefficients, okay? Let f of x be a polynomial function with real coefficients. The linear factorization theorem tells us that f of x can be factored into this form, okay, where zi are complex numbers. Recall, however, the non-real complex zeros occur in conjugate pairs. This is kind of a big deal that you keep that in mind, that they occur in conjugate pairs, along with, since we're dealing with real numbers and we're talking about polynomials, square roots happen in pairs too. They're positive and the negative values. So we have this set up with conjugate pairs. So the quadratic expression, x squared minus 2ax plus a squared plus b squared, whose coefficients are real numbers, is a factor of f of x. Such quadratic expressions with real coefficients but no real zeros is an irreducible over the reals, okay? Now, you'll be asked to leave your answer using the positive version of your factorization as well. So with real coefficients versus imaginary ones in a question. And I'll show you an example of what that'll look like soon here. Factors of polynomials with real coefficients. Every polynomial function with real coefficients can be written as a product of linear factors and irreducible quadratic factors, each with real coefficients. We're going to be working with those irreducible quadratic factors. We're going to do more even with them in section 2.8 when we start working with sign charts, okay, to be able to determine where your function is positive, negative, and 0, and be able to work with those irreducible quadratic factors. We have seen that if a polynomial function is real coefficients, then its non-real complex zeros occur in conjugate pairs. Because a polynomial of odd degree has an odd number of zeros, it must have at least one zero that is real. okay, because it's got to cross the x-axis. Does that make sense? Anytime you have an odd power, you're talking about a cross of the x-axis one way. And the rest of the zeros could be imaginary or irreducible quadratic factors as we're looking through it. So just keep that in mind. If it's even, you don't have to have something cross the axis. If it's odd, you do. So that could be a little check as we go through these. Every polynomial, this is that polynomial function of odd degree. Every polynomial function of odd degree with real coefficients has at least one real zero. That's because it's got to cross that axis. So now, factoring a polynomial. I've got it on my calculator. Okay, write f of x equal 3x to the fifth minus 2x to the fourth plus 6x cubed minus 4x squared minus 24x plus 16 as a product of linear, and please notice how this phrasing is, in irreducible quadratic factors. I won't have imaginary factors in this, okay? Once I get it to that irreducible quadratic, it's part of my factoring as I show the result of my function. Okay, so now I got a list. As I'm looking at it, I got 3 and 16. So if I'm talking about those, I got 16 and 3. The factors of 16, 1, 2, 4, 8, and 16. The factors of 3, 1, and 3. So I have to consider the positive and negative versions of them. So when I'm looking for a list, okay, of factors, I have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. Those come automatically because I'm taking each one of these and dividing them by 1. Okay? Now I'm looking at that same list and dividing it by 3. Okay, because that's the other possible factor I can work with. So the other part of my list becomes plus or minus 1/3, plus or minus 2/3, but now plus or minus 4/3, plus or minus 8/3, and plus or minus 16/3. On previous lists, I've been able to not include every little piece because we've already found that particular possible factor. Okay, the reason I'm including all these is none of the factors have been duplicated. Okay, now once I have my list of possible factors, I can just check my calculator, and this is my calculator check. We're going to pretend I put it in, and I've got my calculator check here. So this is looking like negative 1/3, okay, or in this case, negative 4/3. Okay, this is looking like it's 2/3, maybe positive 1/3 as I'm going through, and those are the ones I'm going to check. Okay, so I checked these things out, and I got 2/3 going on. Okay, and I looked at my calculator to help me with my possibles, and I decided my possibles were 2/3 based on what my possible factors were and what my calculator delivered to me. So now I'm just going to pop this in, drop my 3 down, maybe, if it lets me, and multiply by 2/3, and so I got 2 is my result. Negative 2 and 2 is 0, so I multiply that, and that's 0. And now I got 6, which is really cool. And I find out that this is 4 as my result. And I've got 0 again. And I multiply that, that's 0 as I'm going through. And I'm looking at that, and I've got negative 24. And I divide and multiply, and that's me negative 16. This is my 0. But now I'm thinking, I got a trinomial here. Okay, do you see that I've got a trinomial? And do you see that it's an even trinomial? X to the fourth, x squared, and 0, and in my constant. So instead of continuing with synthetic division, unless they ask me to, I'm just going to start factoring that. See if I can factor it. Okay, so I'm going to go after that right off the bat. I've got 3x squared, or x to the fourth, plus 6x squared minus 24 equals 0. Okay, well I've got 3. I'm going to pull a 3 out to see if it helps me factor. Okay, it's not a really great 8, so we'll put that in there. That's still not a great 8, but I got 8 in there. Okay. Do you all see x plus 4 and x minus 2 as factors? You see it? So I've got this breaking down as 3x squared plus 4, okay, and x squared minus 2 as my factors right now. Are you okay where I got those? Now, keep in mind that x squared plus 4 is an irreducible quadratic factor, unless I pull out imaginary values. I'm going to factor x squared minus 2 one more time, right? Because that's my reals, and it's reducible. I got 3x squared plus 4, x minus the square root of 2, x plus the square root of 2. So my final answer should look something like that. Hi, kiddo. Right in the cup, right on the desk. Thank you, dear. Now, my zeros should be coming up, and I should actually list them because I want to make sure I have those too as well. So I'm just going to include my 2/3. So I got my zeros here. X equals 2/3. Okay, that's that one. Plus or minus the square root of 2 is my other one. Okay, that x squared plus 4, that sucker is always positive, never crosses the axis. Are we doing okay? Questions? Any questions about my factoring? My decision to hop out just because I noticed that it was a trinomial? I mean, maybe you did, maybe you didn't, and you could have just kind of followed through, but it makes it tougher at this point because my next choices were square root of 2s. Okay, that was going to be a tough one anyways, but I like seeing that trinomial and knowing I can factor it, and then going to that next step and solving with using zero product rule. Now, last problem, and it seems like the last two problems, okay, it's kind of connected. A polynomial function has the following complex roots, okay? Now, keep in mind, complex roots have friends, okay? It is now your turn to at least set up the linear factorization where you just take your binomials that you can find, or trinomial, and show me what you'd multiply together to start making your function. Let's call this function P, and the only reason I'm going to call it P is because in question B, we start talking about P of 0, and we're really referring to the function we're finding. So let's call this function P. And see what you can do about setting up your function, the factors of your function, based on the information provided. Remember, when you set these up, always put your pairs of factors together. Always put your pairs of factors together. How are you doing with your pairs? You doing okay? Is it making sense? Yes, no, maybe, possibly. Okay, now remember, this is the nitpicky part of these problems. It's because there are so many opportunities to make an whoops. So be careful about your signs. Okay, the more work you do without finding that shortcut, the more opportunities you make for yourself to have a sign error. I'm going to show you a couple tricks on this, as we go through. Now, my trick isn't here with the x plus 2. I'm going to let that sucker ride for a little while. Okay? My trick is with these guys, and I'm going to point it out. X minus 1 is an actual leading term I'm going to deal with. Then I got minus the square root of 3. Okay? And then I've got x minus 1. And I got plus the square root of 3. And then this last one, before I even write it down, I'm going to combine those terms. Okay? That x minus 5i, x plus 5i is just x squared plus 25. Do you see it? Okay, because of the difference of two squares. So I'm just going to really tell you, x squared plus 25 is what I'm doing there. Okay? Are there any questions about what I've done thus far? Feeling comfortable with them? Now, one of the things I want you to start paying attention to, this is my leading term, okay, in a difference of two squares. This is a difference of two squares in my head, okay? If I look at x minus 1 being like a y, I'll go y, my inside-outside terms will be gone, okay? And I'll just be subtracting 3 at the end. My concern is the reds. So on the red, what I'm going to be doing is x minus 1 times x minus 1. That's my firsts, right? That's a perfect square. So I have x squared minus 2x plus 1 is when I multiply these two values together. Okay? Now, that's my first. My outside terms, x minus 1 times square root of 3. My inside terms, negative square root of 3 times x minus 1. Well, because of the sign change, that's 0. So I'm not going to put those down because I already know they're 0. And now I'm going to multiply the last, which is negative square root of 3, and positive square root of 3, which is negative 3. Now remember, we did this on that previous step. Okay? And then I have yet to touch the x plus 2. Are we okay with what I've done so far? Now, what I'm doing is a shortcut for multiplying as we get going. And now my next one, I've got x plus, I'm going to go x times x cubed, because that's my next thing. It's not a trinomial net, so I'm going to do the two binomials together. I've got x cubed plus 25x plus 2x squared plus 50. Okay, that's this one and this one multiplied together. And then I'm going to combine terms together here to be there. And each time I do it, I kind of step back for a second, you know, and make sure that that makes sense. X cubed, 25x, 2x squared, and 50. And now I'm going to combine those terms here. Excuse me, I lied. Let's go back for a second. Hate it when I do that. Because I want to talk about me taking this x cubed, 2x squared, 25x, and 50 on the top, x squared minus 2x minus 2, and just getting this done. Okay, that's my next step. Because I got my binomials taken care of. It's now a quadnomial, and I've got a trinomial going on. I ain't distributing that. That goes all the way across my page. This is a faster way at this point for me to do my multiplication. Okay, there are other ways you could do it. You guys learned how to do the different lines and combining like terms on the line, on the column, but I like this one better. that's what I've got so far, but hopefully you were doing that on your own, so you got something. And I'm going to combine like terms, and I'm going to write the expression. This is what we've got. This is what we multiplied, and we're looking at writing the expression for 25. I put these together here. I'm going to use them in a second. Okay. Are we okay with the same entries? Are you okay with them? Now keep in mind, a lot of little spots for mistakes. I want to know what happens here when I put in 0 for my negative 25. You know, and I get negative 25 out. Okay, so if P naught is equal to negative 25, write the particular equation. I have everything going on, but for it to be this particular, I'm wondering if there's a leading coefficient that I've got to deal with. Okay, so I'm going to put 0 in for all my x's on this, maybe, if I don't screw it up and, you know, do things weird. We're not going to even worry about that. We're just going to write over the top of it. So I'm going to put in 0 in. I get 2 minus 2 and 25. 0 went in for here, 0 went in there, 0 went in there, 0 went in there. These are my results. And I know that my answer is negative 25. My P is 0. So I'm finding what my A should be. Okay, and I'm just checking to make sure I didn't screw up anything. I got 2, negative 2, and 25. That's negative 100. Over here, that becomes 1 over 4. So that's what my A is. Okay, are you okay with what I'm doing? So now I've got a function with 1/4 in my A because it's particular. They chose the value of 0. And really, I mean, they gave me a y-intercept. My answer should be negative 25 when I'm done if I put in 0. And I pop it in my function. Excuse me, I grabbed the wrong one, so let's get rid of that. But my function, after I finish out, should look like that. If I combine my like terms, now I'm going to multiply it by 1/4 as I go through. And I actually did my factorization down here earlier. We'll just drop it down. My last one should be, I can leave it that way with my P of X, or I can leave it like this. And it fulfills the requirement that 0 goes in and I get a negative 25 as my result. Okay? Questions? Yes, no, maybe. Now, keep in mind as we're working through, I did my multiplication. I used that to get my final function. That's this one right here. Combining like terms and getting it done. I know I just did a cooking show on that one, but just make sure you're comfortable being able to do a problem like that. You will do a couple in your review. Okay? Questions? Remember, the nitpickiness is the issue with this chapter test. There are 8 questions, one of which is extra credit. Okay? And that is the conclusion of what we have today, folks. Okay? So we have that going on, I think, with what we have, 45 to 50. That's actually the assignment that we have up there for day 2. Day 2/day 3. I know this is day 3 as we're going through. Okay? But you started this assignment yesterday, and you are probably in closing distance today for it. Okay, thank you for your time.